Let's see how to solve the circuit. The question is, in the circuit shown below, the maximum power transfer to the resistance R. Here is the resistance between point A and B. We have to find out the power delivered in the resistance in watt. Now we have to solve the circuit. Find we have to find out first VTH or VAB, voltage across point A and B. Now here is the circuit. I have already simplified here. Now the current is here I, and it goes through the junction and divided to current, and at last at the point here will be I, and in the 5 ohm resistance current will be I minus 2. Here is 2 ampere outgoing current, and the current in 5 ohm resistance, here total current I minus 2, so I minus 2. Now find the current here I. Now we can apply KVL in the section A, B, C, D. In this loop we can apply KVL. So the current here is I. It is 5 volt source. Now minus 5, and then I comes to the 5 ohm resistance. Here is I, so it will be 5I, and then the minus 6 volt, and in this branch 5 ohm resistance is current is I minus 2, plus 5I minus 2 equals to 0. So here minus 5 plus 5I minus 6 plus 5I minus 10 equals to 0. So here will be 5I and plus 5I equals to 10I, and minus 5 and minus 6 is minus 11, and minus 10 is minus 21, so equals to 21. So I will be 2.1 amps. Now we have to find out the VTH. I already find out the value of I, so we can easily calculate the VTH or VAB, voltage across the point here and in 2 point. So apply KVL in this section here. Now the section is ADEF. So then first the minus sign of the 5 volt, so minus 5, and then the 5I, so plus 5 into I is 2.1, and plus VTH equals to 0. Here is plus and minus, so minus 5 plus 5 into 2.1 will be 10.5 plus VTH equals to 0. Now VTH will be 5.5. So I have already calculated the VTH 5.5 volt. Now we have to find out the value RTH. Here is RTH. I have already simplified the circuit. When we will find out the value of RTH, then all source will be deactivated. Here the voltage source, it will be deactivated by short circuit, and current source deactivated by open circuit. And 6 volt will be also short circuit here, and in this circuit 5 ohm and 5 ohm are connected in parallel, so RTH will be 5 parallel 5, so it will be 2.5. Now P max will be VTH square by 4 RTH. Here VTH 5.5, so 5.5 square, and it will be, and 4 into RTH. Here RTH 2.5, so it will be 3.025 watt. So it will be 3.025 watt. VTH is 5.5 and for RTH, 4 into RTH is here 2.5 ohm. This is ohm. It will be the result 3.025 watt. Now the next circuit is here. The question is power supplied by the 25 volt source in the figure shown below, how many watt? This is the 20 volt supply. We have to find out the power delivered by the 20 volt source. Now here is a 14 ampere current and 70 volt across the R1, and here is current source is 0.4 I ampere. We apply KCL at the point V. Now we all know incoming current is outgoing current. So here is current I. So I and 0.4 I equals to 14 ampere. So we can write I plus 0.4 I equals to 14 ampere. So 1.4 I equals to 14, I equals to 10. Now we can easily calculate the power delivered by the 25 volt supply. We know P equals to VI. So here V is 25 and I is total current. Here this is I is 10. So 25 watt. This is the answer. The 250 watt power delivered by the 25 volt.